Okay, so we're going to figure out how we can solve this equation. And what kind of equation is this, by the way? It's called a radical equation, yes. Okay, so to do this, we would want to undo the radical using the square. But if I square both sides currently, I'm going to have to FOIL because of the subtraction in between. So the best thing I could do would be, what would be your first step, do you think? Yes, or I would actually, yeah, let's subtract 4 from both sides, and we get the square root of m minus 7 equals negative square root of m plus 7. Yeah? Now, one could argue that maybe I would want to get rid of that negative, but it would just get it, I mean, if I divide this side by negative, it's just going to get it to the other side, so it's not really going to be advantageous. But right now, I can undo this radical by squaring both sides. I won't entirely clear the radical on this side, because what happens when you square this side is you actually have to FOIL. So I can do whatever I want so long as I do the same thing to both sides. That's why I'm squaring both sides, so I keep the equality balanced, okay? So on this side, I would get, and maybe it's better to write it out as the square root of m minus 7 times the square root of m minus 7 equals, and then actually on this side, I can just one step, negative times a negative. Since the negative is included, it's gone. And then squaring that square root becomes m plus 7. Now I still have to deal with this side. And to do that, I'm going to FOIL. So anytime you see that you're squaring something that's technically what we call a binomial, because you have two terms here, two separate terms separated by addition or subtraction, you always have to FOIL this, and that's usually where people make the mistake, is they forget to FOIL. So square root of m times the square root of m is the square root of m squared, or you could have just called that m, right? Then we have the square root of m times negative 7, which is negative 7 square root of m. Inside, you get another one, good, negative 7 square root of m. So if those are actually like terms right there. So that would simplify to negative 14 square roots of m. And then your last, you said, is what? Yeah, positive 49, because a negative times a negative, so we're going to put plus 49 equals m plus 7. Normally I would like my equal signs to line up, but this got a little wide here. So plus 49 equals m plus 7. What should I do to solve for m now? Now I have m all over the place, right? Yeah, so what do we want to do? What's our goal? We want to get everything, and actually, because I want to use that square, I want to actually isolate the square root of m, because I haven't actually cleared all of the radicals yet, right? So if I get everything onto one side, subtract m from both sides, subtract 49 from both sides, and I'm going to get negative 14 square root of m equals, because that's the only thing left on that side. This is gone. Actually, now that's gone. And then we have equals to negative 42. Is that right? Yeah? Yeah. Okay, good. Check my math. You got to check my math, because I can be wrong sometimes. Now, what could I do now? There's actually two different options. I could square both sides, but that's a really big number, and I happen to know that 14 squared is 169, but not everybody does. So I might divide both sides by the negative 14 just to further isolate that square root of m. And then we could reduce that fraction. I know both of these numbers are divisible by 7, and a negative divided by a negative is a positive. So if I divide this one by, why don't I even just divide it by negative 7, just to show that it's going to go away, but it's fine there too. I don't really have to put the negative 7, but anyway, 6 over 2, wait, I could have actually gone further. 14 goes into 42, who knew? Okay, so let's just reduce that further. What's that going to be? The square root of m is equal to 3, right? 6 divided by 2 is 3. Now what should I do to get m by itself? I want to isolate the variable. It's not yet isolated because the square root of m is not the same thing as m, right? In fact, it's m to the 1/2 power. I don't think that helps, but just because we've been talking about exponents, might as well write it that way. And what's so cool is when you square both sides, the square root is undone by the square, and you can actually see that you would multiply exponents there. 1/2 of 2 is 1, so you have m to the first power, which is m, equals 9. Now, that's all well and good. If we did everything right, we would get 9, and we could put it in set notation. But how do we know if it's correct? Check it. Very good. So to check it, what do we do? Yeah, so I'm going to go back to the original question, and wherever I see an m, I'm going to plug in 9. So I had the square root of m, which is 9, minus 3. Is it equal to 4 minus the square root of 9 plus 7? And so here we get 3 minus 3 on that side, and then that would be 0, good. And then we have 4 minus the square root of 9 plus 7 is 16, and conveniently, 4 minus 4 is also 0. 0 equals 0, and that's correct. Since the check worked out, I can be confident that my answer worked out. And so we always do want to check, because sometimes we can get answers that actually don't end up working out. Through the squaring, we can end up, it's not that we've made a mistake, it's just that sometimes there are answers in life that have no solution. In fact, you know, there's always this saying, oh, math, it gives us hope that every problem has a solution. And to that I say, no, that is not true. Even in math, we have problems that have no solutions. So